In the mechanical CAD courses, students learn to use sophisticated 3D modeling software to create virtual models of real-world parts and assemblies. Some of the benefits of creating virtual 3D CAD models is that it allows designers to study how components go together to form assemblies, as well as identify potential manufacturing issues before committing the design to production. This series of courses is designed not only to help the students develop 3D modeling skills, but also to gain an understanding of how things go together and learn about real-world processes involved in going from conceptual design to fabrication and then final assembly of a product. To emphasize this, the students are given a project that simulates these real-world processes. The end result of the project is a ball valve assembly, which is really nothing more than a quarter-turn valve that's used to control the flow of liquids or gases. In the early stages of the project, we cover topics like creating detailed drawings for use in manufacturing, as well as creating technical illustrations that show how assemblies go together. The final stages of the project revolve around creating a physical prototype that's made up of both machined and 3D printed components. For the machine component, we collaborate with SPSCC's Advanced Manufacturing Technologies program. In this collaboration, the CAD students visit the manufacturing facility where they get an introductory lesson on the machining processes related to the ball valve component. Afterwards, they're given a tour of the machine shop where they get to witness their parts, as well as other parts, being fabricated by students in the Advanced Manufacturing program. This experience is priceless. The students walk away inspired and with a real sense of the bigger picture. The remainder of the components are then created on our 3D printer. Once all the components are ready for assembly, they're given to the students along with some off-the-shelf hardware and the tools necessary to complete the assembly. So this is where the students get to see if their parts actually fit together, and if not, they need to figure out where they went wrong. I believe this process plays an important role in demonstrating to the students how the accuracy and quality of their work affects downstream processes and ultimately the end result. I like to tell my students that if things aren't going the way they should, embrace it as an opportunity. A lot of learning happens during the troubleshooting process, and when you finally figure it out, you get this real sense of accomplishment. If things are always going the way they should, you might actually be missing out on some valuable experiences. The days of being a CAD operator, sitting behind a computer for 8 hours a day with the headphones on, is pretty much a thing of the past. Employers really expect you to know more than just how to create drawings. If you have an understanding of manufacturing processes and you know how things go together, you're going to make more informed decisions as a CAD operator or designer. You'll also be better equipped to identify potential design flaws and communicate with engineers to resolve those issues before the design goes to manufacturing and potentially costs the company a lot of money. Having peripheral skills related to CAD, hands-on experience, and some knowledge of manufacturing processes is essential to being competitive in today's job market.